My name is Nathan Weigel. My field studies placement is at a solar energy lab, and my supervisor's name is Ravi Subramanian. The lab is located at the Paul Laxart Middle Engineering Center, located on campus. The building was established in 1983 in order to develop new technology and further science. The colleague that I was mainly working with is Brad Allard. The mission statement provided by my supervisor is to harvest solar energy by using inexpensive and benign materials. Solar energy is crucial for life on Earth. It grows our food, generates electricity, and provides heat. There are two main types of solar energy: photovoltaics, which is creating energy, and photocatalysts, which is speeding up a reaction either by hydrogen production or dye degradation. Currently, the U.S. energy consumption predominantly comes from three types of fossil fuels: coal, natural gas, and petroleum. Only about 8% comes from renewable energies. The problem with fossil fuels is that their supply will eventually run out. They also have adverse health effects on the environment and human health. Renewable energies like solar energy can reduce the global impact of fossil fuels by providing a clean energy that is abundant in nature. Synthetic dyes are commonly used in clothing to give it its distinctive color. For example, indigo is the most common used synthetic dye in denim. The problem with synthetic dyes is that they're not being appropriately disposed of in landfills. They potentially have the risk of altering soil chemistry and/or contaminating groundwater. With the research that we are conducting, we could possibly change the methodology for the disposal of dyes. For the sake of our lab, the material we used is bismuth titanate, otherwise known as BTO, doped with either lanthanum or iron. The way it works is broad spectrum light hits the BTO, ranging from UV to infrared. Certain wavelengths are absorbed based on the specific BTO band gap. A smaller band gap requires less energy to excite an electron. This allows BTO to absorb and use lower energy light. Most of the sun's energy is visible, so a small band gap allows us to use more sunlight. The energy that is absorbed will assist in breaking down the synthetic dye into a safer byproduct. The leftover byproduct is ecologically neutral and safer for the environment. The instrument that you see on the top right is used to measure the yield of hydrogen produced by BTO doped with iron. In theory, the more hydrogen that is yielded, the more appealing this product becomes because it is cost-effective and efficient. Our goal is to store energy from sunlight in the chemical form of hydrogen. In conclusion, the data displays that the most effective amount of iron is 2%, concluding that there is a balance between maximizing BTO sensitivity and efficiency. The iron increases the sensitivity to absorb light energy, but decreases its efficiency in using that energy.
We put the sample of BTO in this cylinder with a solution of methanol and water. And then here we have a temperature probe to tell us how hot it's getting inside, hopefully not too hot. And then we've got a gas line here that goes down into the water that bubbles out argon, so we can replace all of the normal air with something that we know. And then our hydrogen escapes through here. So we have this cylinder, which is hollow, but it has a jacket. We set it in there and tighten it down to seal the chamber. We run water through these lines that goes around the outside of the jacket to hopefully keep it nice and cool. And then inside the center, we put this light, which is really bright. And when we turn that on, it shines the light on our BTO. We then stir it so that we keep everything mixing nicely. And when it's producing gas, it comes out through this line into this chamber, and then continues on through here and into this cylinder full of water. And so as it bubbles, the water comes down, so we know how much gas we produced. We can then take a small sample out of here and put it through a machine that tells us what's in the gas. And it gives us a percentage concentration of hydrogen. So knowing that concentration and how much gas was produced, we can calculate a volume of hydrogen that was produced.
Limitations to solar energy are the efficiency, it requires sunlight, and our current grid doesn't allow us to store it. Scientists from all around the world are contributing to a much larger global scale solution. Renewable energies will also create greener jobs and reduce the amount of unhealthy jobs